Hello everyone, myself Subham, and I am a student of IIT Patna. And in my MSc project, in my MSc assignment, I get the topic structure factor and form factor. So this is the XRD pattern of a gold nanoparticle, and this is XRD pattern for baby TiO3. So in this XRD pattern, we observe some peak here for one plane, and for 200 plane, we observe a small peak. And also for 220 plane, we observe a small peak, and for 311 plane, we observe a small peak. And we also observe that some planes are not included here. Similarly, in this case, we observe some peaks, and there is no peak here, and there is a small peak here. So these peaks basically depend upon atomic scattering factor and structure factor, or we can say the geometrical structure factor. So atomic form factor basically is related with the number of electrons, or we can say that atomic number. So for any jth atom in unit cell, F is measures the scattering power of the jth atom in the unit cell, and scattering by an atom is directly proportional to Z, theta, and lambda, where Z is atomic number, theta is diffraction angle, lambda is the wavelength, and F is the amplitude of the wave scattered by an atom upon amplitude of wave scattered by an atom. And this is the graph of scattering factor of the carbon atom, where F, that is atomic form factor, with the sine theta by lambda, dependence of F with the wavelength is represented here. And uh, this diagram is represented that the form factor of Na plus is less than Cl minus. So in case of Na plus, we have 10 electrons, and in case of Cl minus, we have 18 electrons. So light is diffracted from uh, electron of Na plus, and in this case, light is diffracted from electron of chlorine. So the atomic form factor depends upon the number of electrons. So in case of chlorine, the number of electrons are 18, and in case of sodium, the number of electrons are 10. So the atomic form factor for chlorine is greater than the atomic form factor of the Na plus. Now, structure factor. Basically, structure factor refers to the geometrical structure of the crystal where the atoms are placed. So we know that with the help of unit cell, we create the whole crystal structure, and scattered waves from various atoms in unit cell interfere to create the diffraction pattern. And this is a body-centered cubic cell, and the light is diffracted from different planes. In this case, we can see, and suppose we have two different type of atom, A atom and B atom, then the atom amplitude of the scattered amplitude depends upon the weight by the atomic scattering factor. That is, weight of the atomic scattering factor help us to determine the scattered amplitude by atom A and scattered amplitude by atom B, and the resultant amplitude of all waves scattered by all the atoms in the unit cell gives the scattering factor for the unit cell. Is structure factor represented by the F, and it is given by amplitude of wave scattered by unit cell divided by amplitude of wave scattered by an atom. Earlier we said that in case of atomic form factor, amplitude of wave is scattered by an atom divided by amplitude of wave is scattered by an electron. But in case of form factor, we have the amplitude of wave is scattered by a unit cell divided by amplitude of a wave is scattered by an atom. And as we know that intensity is directly proportional to the amplitude square. So an intensity that we observe in peak that we observe in XRD pattern is directly proportional to the structure factor. And one more important thing is structure factor is independent of size and size of the unit cell. And F structure factor is given by summation Fj e to the power iota phi j, where basically J represents the number of atoms and Fj is the atomic form factor for a different number of atoms, and we can write this to be like this: 2 pi h x dash j plus k y dash j plus l z dash j, where h, k, l and represent the Miller indices and of the plane, and x dash j, y dash j, and z dash j represent the coordinates of the atom of jth atom. Now, structure factor for simple cubic. So, in case of simple cubic, suppose we take an atom at origin, that is 0, comma 0, comma 0. So, and we know that the effective number of atoms in simple cubic would be 1. So, structure factor, we have one atom, so there is no summation here. So, fj to the power iota phi j, and we have Miller indices would be h, k, and l. Now we have the coordinate x dash j, y dash j, and z dash j to be 0. So the form factor, structure factor would be like this: f into e to the power 0, that is equals to f. So f square is equal to small f square. So from here we conclude that in case of simple cubic, all planes are allowed. Scattering would be done by all planes. No planes are rejected in case of simple cubic. Now, structure factor for body-centered cubic. So, in case of body-centered, we have effective number of atoms would be 2. And suppose one atom is represented as 0, 0, 0, and another atom that is at body center would be at half, half, half. So here we have two atoms. So we have summation j is equals to 1 to 2. So we represent f into e to the power iota 2 pi into this plus f into 2 pi into this. And after solving, we get f equals to 1 plus e to the power pi h plus k plus l. And that quantity would be real. And we know that h plus k plus l are integer. So we have two cases when h plus k plus l is even and h plus k plus l is odd. So when h plus k plus l is even, so this becomes 1. So we get f equals to 2f, and f square is equal to 4f square. And the planes are 1, 1, 0, 2, 0, 0, 2, 1, 1. These are even. These are planes whose h plus k plus l sum is even. And when h plus k plus l is sum is odd, then we get e to the power iota pi. Suppose this is would be 3, then this would become -1. So f1 -1, that becomes 0. So we cannot observe the planes whose sum h plus k plus l sum is odd. In case of body centered, these are not allowed planes. Now we are talking about the structure factor of face-centered cubic. So in case we have effective number of atoms 4, and these are the equivalent positions: half, half, 0. Another is 0, half, half. Another is half, 0, comma half. And so in this case we have 4 atoms. So the structure factor would be like this: the form factor into summation of 1 to 4, and we can simplify this would become like this. And more simply, f is equal to 1 plus e to the power iota pi h plus k, e to the power iota pi k plus l, e to the power iota pi l plus h. And when h, k, l are unmixed, that says that when h, k, l, all three are either even or either odd, or completely even or odd. Or when h, k, l are mixed, suppose we have h, k to be odd and l to be even, then these are mixed indices. So in this case, f is equals to 0 and f square is equal to 0. So these are the planes: 1, 1, 1, 2, 0, 0, 2, 2, 0, 3, 3, 3, 4, 2, 0 are allowed in case of a face-centered cubic. And in this slide, we can see more clearly for mixed indices or unmixed indices. So we have two cases, case A and case B. Suppose H, K, L are in H and K are odd and L is even. So when H, K are odd, then we get 1, 1 plus 1 minus 1, 0, and the form factor would become 0. And suppose h is odd and k and l are even, then we can also get f to be 0. And this is for unmixed case when h, k, and l all are odd or either even 2 2 2. So in this case also we have two cases, H, K, L are either all three odd or all three are even. So in this case we get 1 plus e to power even. So this would be 1 1 1 1 4. And when these are odd, uh, then we can also get 1 plus 1 plus 1, that is 4. So the when H, K, L are unmixed, in that case we get F is equal to 4F, F is equal to 16F square. Thank you.